All right, so we're going to get into our chapter on statistics, probability and statistics. So what we're going to talk about today, we're going to start with something called using sampling to predict. All right, so we'll talk, this whole lesson, majority of it is on sampling. But the math part of it is we're going to use it to predict, to come up with a conclusion or to just predict an outcome. All right, so how many of you guys remember, like in elementary school, and I remember doing this when I was in elementary school, but some of you guys may also remember it, and not that everyone did this, not that every teacher did this, but at some point during your school life, you walked around a little piece of paper and you're like, what is your favorite color? Right? And you tally it up, and then maybe your teacher had you like come up and build a little bar graph with your results, and you basically did like a survey. Right? How many of you guys did something like that in elementary school? All right, a lot of us, right? So, all right. So, what we're talking about, this is actually more of like adult-based surveys. That's kind of what we're talking about. Okay, and that's kind of the whole idea. But we're gonna kind of get into some of the specifics on how to do it the right way. I'm sure that wasn't a complete focus when you were in elementary school, but with mathematics, you're going to do math the right way. You've got to do that the right way, the sampling. So here's let's go through. Like I said, a little warning. Lots of vocab in this, but like I said, that's almost the whole lesson is on vocabulary. So if you understand the vocabulary, you'll be all right. If you don't understand it, make sure you use your notes on your homework. All right, here we go. The first word is population. Everyone?
Population.
All right, so it says a population is a larger group used in statistical analysis. Larger group used in statistical analysis. All right, so for example, this is who you are surveying. Now, when I teach this every year, I kind of get into when we talk about sampling, right? I always think of like doing a sample, and I don't know if any of you guys have been there, but my family and I, we sometimes, my wife and I, we take my daughter to our little treats. Sometimes we go have bagels certain mornings when we have an opportunity, if it's summertime or on the weekend or whatever, and we always like going to a little place called Uncle Harry's. I don't know if any of you guys have heard of them. There's not really a lot of them in Clovis, but Uncle Harry's Bagels have all these like really good, like different bagels. They make sandwiches, they make a lot of different things. But if, especially my daughter, because she's picky, and she doesn't like everything, right? That's what part of being picky is. But if she wants to, if we're going to order a bagel, we want to make sure that she's going to eat it, right? We don't want to spend the money for the bagel and then she lets it go to waste and then she's like, oh, I'm still hungry. So what we want to do is make sure that if we're buying it, she's going to enjoy it to, eat it. So they have all these different bagels. And so let's say, for example, she's pointing at a bagel that she likes the way it looks. Let's say she just thinks it has freckles on it or something, right? Because that's what little girls or little boys, little kids sometimes do. Oh, that has freckles. I want to try that one, right? But maybe let's say it's a garlic bagel, right? And I'm thinking, I don't know if my daughter's going to like this garlic bagel, right? So I want her to try it. Now, first of all, I am not, if I want her to try it, am I going to ask for every single here, please take out that tray. I want every single garlic bagel that you have in there. Is that what I'm going to do? No, right? Now here's what I'm getting at. Every single, she wants, right? It's not every single bagel in there, but what she wants to know is if she likes the garlic bagel. So what she's doing is, what I'm saying is all the garlic bagels would be considered like the population. It's what she wants to try out. It's all of those garlic bagels. Okay? Now, you're saying, well, where are you going with this, Mr. Wilkins? Well, because the next word is sample, everyone.
Sample.
All right, so your book says this is a subgroup or a subset of a population used to represent the whole population. So in your little box here, go ahead and put same as sampling food, exactly what I'm talking about. Same as sampling food. So instead of me ordering or grabbing and having her eat all of those garlic bagels to try it out, right, before we actually buy one, they have a little container up top. And I, of course, grab one of those little pieces that have a sample of a garlic bagel and have her try it before I buy a whole one, right? So that's, of course, what a sample is. All right, it's not all of the garlic bagels, it's just a part of it. All right, or part of one, just to try it out, to see what it tastes like. If I taste that garlic bagel, more than likely, or I should say she tastes a little piece of garlic bagel, is that going to give us a pretty good idea if she's going to like a garlic bagel? Yeah, absolutely, because it's a sample. It's a little piece of what that is. Just like sample is a little piece of the whole population. Okay? So, there are two major types of samples. Okay? The one I'm going to start talking about is an unbiased sample. Everyone?
Unbiased sample.
Well, if this is unbiased sample, what do you think the other kind of sample is?
Biased.
Biased sample, right? So, let's focus here on an unbiased sample. This says this is a random sample that is representative of a larger sample. A random sample that is representative of a larger sample. So in your little box there, go ahead and just put, this gives us good info. All right? It's not so much a synonym, it's a little description. This is going to give us good info to have an unbiased sample. Now, before I get deeper into what this is and get more specific on this lesson, just going back, just kind of ending the little bagel comparison. If I reach in and, first of all, I have all my garlic samples, my garlic bagel samples, right? And to give her. Now, I need to be careful. I need to make sure that that sample that she's going to try tastes just like the one I'm going to buy. So, first of all, I can do a number of good, let me start with this. I can do a number of bad things, all right, which is going to be bad info, which you probably can draw a conclusion we're going to get to in a bit. It's called bias sample. But I can do a number of bad things. First of all, I could say if there's all the samples up there that were pulled out of the oven the same time as all those other bagels that we're going to buy, right? I can then look over and tell the girl over on the side, oh no, ma'am, can I please have that hot, fresh garlic bagel you pulled out of there? And then she cut the little piece, and my daughter's like, this is great. It's fantastic. And then what do? I buy her a bagel that's like room temperature. She doesn't like it. Well, it doesn't match up, right? The one coming out of the oven doesn't match up with what the big one I just bought. Or, better yet, I can go to Panera and give her a little sample of their garlic bagel, and then go buy her a bagel over at Uncle Harry's, right? Either way, that would be foolish, right? It's because it's going to not give us the right kind of information we need. There's little problems with it. It doesn't match up properly, okay? What am I going to do? No, I'm going to go ahead, I'm going to grab a sample of the bagel that is garlic, have her try it, and it should match up directly with what I'm about to buy. That good sample is what we can consider like an unbiased sample. There's nothing wrong with it. It's good info. Okay? Now, I'm going to end that there, but I want to get into, we're going to talk about what makes a sample a good sample. What makes it an unbiased sample. So if you're, going back to what we talked about earlier, like you're in elementary school and saying, what kind of color is your favorite color? Well, you're more than likely, probably the title of your survey was something like, elementary school, or maybe it was whatever elementary school you went to, that elementary school's sixth graders' favorite color. Obviously, if you did it last year, you're asking your sixth graders, right? So that would be what you're talking about. Okay, you need to make sure that your sample matches the population. Okay, you don't want to go and ask fifth graders. So you don't want to go and ask elementary, different elementary schools, sixth graders, if that's not in your title. Okay, so we're going to talk about what makes a sample a good sample. All right, so here we go. These are all types of unbiased samples. Actually, we're going to start with just defining. Remember, unbiased sample said it's a random sample. So they just want to take a quick second and define that word, random. Everyone?
Random.
Okay. This is when outcomes occur at random. It says outcomes occur at random if each outcome is equally likely to occur. Your little box, flipping a coin. Think about it. When you flip a coin, what can you come up with? Yeah, right? Heads or tails. Heads or tails on this quarter right here. Okay? So, if I flip this coin, all right, if I do something like this, okay, I am going to try to flip heads. I just flipped heads. Ta-da, I won. What did I just do? I'm a terrible flipper?
Yeah.
All right? You're right. I am a terrible flipper. Guys, it's the flip that makes it random. When this thing turns over and over and over again 10 times, that's what makes it random. If I strategically, if I flip that, I'm gonna try to get, you're gonna buy me lunch or I'm gonna buy you lunch. It all depends on what I flip. Okay, I'm gonna choose heads, and then I do that. What would you call me probably? A cheater, right? A cheater. It's all right, a cheater. Okay, and we say that because I wasn't fair. I didn't do something at random. You go to a sporting event. You don't even have to be an athlete to know this, more than likely. At the beginning of many games, to find out who gets the ball first, what do? A lot of times, not all the time, but a lot of times they flip a coin, right? But that thing flips, and it, of course, half the time, depending on the sport, it might even land on the ground, and then they look. It's random. We don't know which side is going to come up, right? Well, that's just a quick definition. I shouldn't say quick, but that's an example of what random is. All right, that's really important when you're getting sampling done. Okay, you need to make sure that everything is random. Okay, so going on with unbiased sample, here we go. The first one, the first type of unbiased sample is a simple random sample. Everyone?
Simple random sample.
Okay. This is a sample where each item or person in the population is as likely to be chosen as any other. Okay? Now, for example, if you want to know what all 7th graders in the entire United States, what is their favorite video game? Okay? If you want to know what their favorite video game is, are you going to be able to ask the whole population? No, and I probably should have said that at the beginning. No, that's the whole purpose of a sample. I talked about bagels, right? It's kind of unrealistic to try every single bagel, but when it comes to actual surveys, you can't ask the whole. It's not realistic to ask the whole population. You have to ask a part of it. Okay, something that represents the population. Okay, and so when it comes to a sample, a simple random sample, what it says, a sample where each item or person in the population is as likely to be chosen as any other. Okay. So, for example, let's say they're trying to pick a winner of getting a new car. And Department of Motor Vehicles, DMV, is in charge of it. Okay, not that this would ever happen, but you guys get the idea. So in their computer, they just hit they put on a certain mode and it just goes and it just randomly selects 30 ID numbers, all right? Maybe California driver's license ID numbers, okay? That would be an example of a simple random sample. Maybe something done by a computer like that. Okay, being a little more specific, all right, here's another good unbiased sample. This is called a stratified random sample. Everyone?
Stratified random sample.
All right. This is where the population is divided into similar overlapping groups. Then a simple random sample is selected from each group. Okay, a simple random sample is then selected from each group. So an example that is on here, it's a kind of a longer one. I believe this is in your book as well. So a population of election districts can be separated into urban, suburban, and rural strata. Okay. Maybe to talk about this in terms of, let's say, I say, okay, guys, all the 7th graders in California, what is their favorite car? What kind of car do they, what's their first car that, or maybe what's their, let's say, their dream car? Okay. So here's the thing, right? If I'm asking you guys that question in this class as a survey, and let's say someone in, I don't know, let's say like, just because it's so, typical of what people would say, like, let's say they ask the students in a 7th grade class in a place like maybe like Beverly Hills or something like that, right? Where maybe my whole house is the size of their living room. All right, you guys get that idea, right? So they're people that when it comes to money, they have more funds for one reason or another, right? So here's what I'm getting at. If I ask you guys, your guys' answer would probably be a lot like mine. You'd probably be thinking of terms of like, oh, a Mercedes or a BMW SUV or I don't know, like everyone like has their I don't know, even like an Escalade, I don't know, something like that, right? But over there, their responses may be stuff like oh, a Maserati, or like cars maybe some of you guys have never even heard of, because maybe these cars cost $200,000 to $300,000, as much as like maybe my house. Okay, so here's what I'm getting at is that if I want to know about the state of California, this one is saying, well, I'm going to separate and get samples out of each type of place, because if I just get it out of one type of place, it's not going to give me accurate information. I want to get it out of every single place, and that could maybe be representative of all the 7th graders in California. So we would only be maybe a part of that. Maybe they just, like I said, they come and get a few from here, a few from different areas to represent the whole population of 7th graders. Okay? Not that our choice or their choice would be wrong or right. It's just they want a accurate measurement. Okay? Now comes a systematic random sample. Everyone?
Systematic random sample.
Okay? Your book says this is a sampling method in which the items or people are selected according to a specific time or time interval. So this is a pretty decent example. Every 20 minutes, a customer is chosen. Or every 10th customer in line is chosen. I don't know what that would be, but kind of creating a fake story, right? Like, everyone is walking in Target, all right, and they're having some special thing where they're giving out free TVs that day. So what they do is like they said, every 20 minutes a buzzard goes off, and whoever's like closest to an employee or something, they're chosen for a free TV every 20 minutes. Or maybe when people are leaving, every 10th, you just say 1, 2, 3, 4, and then once you get to number 10, you go, okay, you want a free TV, and then you count the next 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you want a free TV, every 10th customer. Okay, so it kind of gives you an idea of what a systematic random sample is. It's random, you don't know who you're going to choose, but there is a system to it every 10th person or every 20 minutes. Okay, so that's what it means by every specific time or time interval. All right, here we go. Now we get to the other side of things. Okay, those are 3 unbiased samples, which you'll have a bunch of questions on, or some questions on. Now we talk about the other side of things. What makes a biased sample? So biased sample, everyone?
Biased sample.
Okay, we referred to this earlier, right? This is a sample that is not representative of a population, right? This was like going back to the bagel story, like me going to the Panera to get a bagel whenever I'm buying one. I'm actually going to, to try a sample from Panera, I'm going to buy one from Uncle Harry's Bagels. Okay? So one that's not representative, or picking the hot one out of the oven when it doesn't represent the ones that I'm going to buy. This gives us basically not good info, all right? Inaccurate info. All right, so here we go. Here's some biased samples. First of all, what could make it biased is a convenient sample. Everyone?
Convenient sample.
Okay, so this is a sample which includes members of the population that are easily accessed. You have if you're doing the survey, you have access to those people, so you choose them. Hey, why? Because they're convenient. They're right there. Even you might be like we were just talking about, right? You might be asking, oh, what's California's, 7th grader's favorite dream car? But you only ask the people here. Why? Because this is the school you go to. You don't want to travel. You don't want to get on the phone to call people randomly, 7th graders, to ask them, right? So you just ask people here. But like we talked about earlier, that could give us bad results. That wouldn't be maybe completely accurate of what it would be in the whole state of California. Okay? So the sample I have, or the example I have, it says the first 10 students in the cafeteria line. So here's an example going off of that. They're going to find out, hey, who's your favorite teacher? That's what they're going to ask students going through the cafeteria line, right?
I don't have one.
So guess what they all say?
Nobody.
They say the teacher that the class they just come out of. Why? Because the teacher let them out early to go get lunch. Right? See how that could be a little misleading? Maybe every other day they don't like that teacher, but for right then they like that teacher because they got to get in the front of the line. Okay, so I mean there's little weird things that can happen like that. So that's one of the problems with a convenient sampling. All right, here we go. The next one, a voluntary response sample. Everyone?
Voluntary response sample.
All right. This is a sample which involves only those who want to participate in the sampling. You're not getting everyone's. You just say, hey, if you want to, give me a feedback, please do so. So I had that one up there. An email was sent asking seniors where they want to have their graduation ceremony. Do they have to all respond?
Yes.
No. It's just an email, random mass email sent out to the seniors. Maybe the only high school seniors who respond, right, are maybe the non-athletes. Because why? The athletes are at practice. Maybe when the email was sent out, maybe they cut off the time before they got home, or maybe the people who have during finals week, and the people who have, honors classes, guess what? They're studying for their finals. They're not checking email. So all of a sudden now, all the people that are just playing video games and maybe not going to pass or whatever their senior year, they're the people answering this email. So it's going to be biased. I always say this. I love shopping off of Amazon. Amazon is saves me time and gas money. Okay, to shop if it can be shipped to my house. But in all honesty, sometimes I have very bad results on Amazon. Okay, every once in a while I'll get something that's the wrong item. The item is partially broken. It doesn't even look like it did online. It doesn't fit the description. Whatever the case. So before I buy, I always check the reviews. Right? Now you have to understand though, most people who give reviews, right? It's all voluntary. You don't have to give a review on your when you bought that item. It's all voluntary. Okay, so you kind of have to, it's good to look into, but you have to kind of strategically look at it because guess what? A lot of the people that give reviews, in my opinion, like I think that most of them would, if you love the item, like for some reason it is the best item ever, you might be motivated to get on there and give a review. Or if the thing is horrible, half broken, and you had a hard time returning it or whatever else, you may give a bad review. Sometimes the middle sections, the people that are just kind of content with it, it's just kind of doing its job, whatever they ordered, and they may not be motivated. They may be busy, may not have the time to go on there, and they don't make it a point because they're not extremely happy or they're not extremely angry with their purchase. So, when I get on Amazon, I always look what I look for? I look for patterns of things that maybe went wrong with the item. If there's no pattern, then I'm like, oh, okay, there's random things that go wrong with everything. But if there's something that happens to a bunch of people, then you're like, oh, that might be a defect in the item, right? So you got to watch. You have to think smart and watch when you look at stuff like that, which are results to, for example, surveys or questionnaires, okay? So anyway, voluntary response sample. Any questions? Okay, what we're going to do is we are going to start on this finally. There's actually not very many problems we're going to do, or many types of problems, I should say. But what you're going to see me do is I'm going to keep these sitting right by me because I'm going to refer to them throughout. I'm going to try to match them up with the description and maybe the example. They're not all going to fit exactly, but it will give me at least a good idea of maybe what I'm looking at. All right. So thank you those of you that have papers out. Name, date, period on top. All right, here we go. Let's take a look at page 464. Bless you. Okay, here we go. Number one, let's close. Actually, let me just read the directions. Directions, guys, of course, are very important. It says, identify each sample as biased or unbiased and describe its type. Then explain your reasoning. Okay? So, they want three things. They want biased, unbiased. They want what type of bias or what type of unbiased sample is it. Okay, that's what was all in our vocabulary. And then they want us to kind of state why it fits that. All right, so just a quick little sentence on why it fits. All right, so here we go. Let's go ahead and close read number one. Number one. Okay, number one says, to determine how many students at a middle school bring their lunch from home, all the students on one school bus are surveyed. Okay? Now, first of all, let's go ahead and and guys, these are a lot of these are mental notes, and they're just directions to follow, but there's no calculations. So we're going to put step star. Okay? who's the population? Meaning, who are they wanting to get the information from? Not the school bus. That's not the pop. That's a sample. To determine how many students at a middle school bring their lunch from home. Students at, it says, a middle school. So that middle school is what I'm assuming. How many students at the middle school? All the students. All 7th, 8th grade students. All of them. Okay? Now, I need to keep that in mind because that will help me realize, does the sample fit that? All right? So, step 1, okay, we want to know biased or unbiased. Okay? So, let's take a look. Who did they ask again? School bus kids, right? So, if I take a look at the school bus kids, I want to know, right? Biased or unbiased. So if I take a look, here's all of our unbiased. Are they chosen at random? Is the school bus chosen at random? Here's one, stratified random sample. Are they dividing them into smaller parts? But remember, even when they do this, they have to choose the kids at random, the 7th and 8th grade middle school students. Systematic random sample? Are they chosen every 10th person on the bus or every... No. Well, let's keep this in mind. What about biased? Is it a convenient sample? Only asked one bus? It wasn't voluntary, right? No. All right, they didn't throw some out there. Only asking one bus, guys. All right. That is a biased sample. Okay. Step 2, which is just say, I'll just put which, meaning which, in this case, which biased one. And we just said it's not voluntary. What would it be? Yeah, convenience. It's a convenient sample. Okay, they want to know how many lunches come to middle school, right? Or how many, what do they call it, sack lunches, or lunch from home is how they described it. Okay? Well, think about this. If you're asking, and it all depends on the school district and their rules, okay? But if it's asking different school buses go to different areas, right? So let's think about this. When a school bus, if a school bus goes, I mean, there could be a school bus that goes in one spot and another school bus that goes to the other. Well, I don't know about you guys, but I live in a regular middle class neighborhood, but one way, if you go one way out of by my place, you're going to run into homes that are tiny, not kept up. The economic status a lot of time for those people are they don't have a lot of funds for one reason or another. Okay, and then you can go down the other way, down the street the other way, and you, like I said, you have homes that are like 2-story with an attic and maybe a basement, and they live on 5 acres of land, and the thing is huge. It's like 4 times the size of my house. Okay, what I'm getting at is the bus. One bus might go in one area, the other bus might go in the other. Now, if you're bringing a lunch to school, okay, and that could work both ways, right? At school, right? Someone could bring a lunch. Maybe they make a nice simple sandwich, have some simple chips out of a bag of chips and a beverage of some sort, a juice or whatever. And then other people, what do? They go to the snack bar, flop down a $20 bill and say, I would like to buy my food and everyone else's food around here or whatever else, right? And obviously, bringing a sack lunch might represent someone that is trying to save money. Now, not all people from low, I personally, I try to be very thrifty and save money myself, okay? And I probably could afford to buy things, but I try to save money and use my money more wisely, okay? But my whole point is that buses go to different areas. And those different areas may have different economic status, which may affect people bringing their lunch themselves or just bringing cash to school to buy their lunch, right? So because of that, all right, I could put something like what I just said. Different buses may travel to different neighborhoods, and maybe in parentheses I could put economic status, meaning how much money the family has. And that, of course, could affect, like I said, if people bring their lunch or not. Some people may figure on the other way, it's easier, right, to bring a couple bucks and buy from the snack bar. Some people bring extremely extravagant sack lunches, maybe, and some really good stuff in it, and that would be more expensive than the snack bar stuff. It's different ways of thinking about it. But bottom line is this right here may affect the results, because it's all about convenience. I'm going to choose that last over there, and that bus is all from one area. Now, guys, listen. This lesson is very vague. It's very, let me look at my sampling, biased, unbiased. It's some critical thinking involved. Okay? It's not 2 + 2 is 4 sort of math. All right? So this is a different side of mathematics. All right? So use your notes, use your vocabulary. All right? Just don't forget, and sorry, I just did step 3 without mentioning it. All right? I'll put the why. So first of all, think of your population. That tells you if the sample's matching. Okay? We're looking for all students. That's what was affected. We're not sampling all types of students. Okay? So it's biased because it's a convenient sample. And then, of course, we just talked about why it's considered a convenient sample. Okay? And why it's wrong. Any questions? I'm going to have you guys try one. And then discussion will happen, and that's good. All right? We can talk about it. Here we go. Here's one I want you guys to try. Page 465, problem number 6. All right. Anyone need more time? Okay. All right. Check in with you guys in about 30 seconds or so. Okay. All right, 30 seconds. I tell you what, I'm going to give you about 1 minute because sometimes these discussions on this lesson, it lasts a little long. And there's nothing wrong with the debate. Just please make sure, okay? Make sure you back it up with information, not who can get louder, right? So a healthy debate is not a bad thing, but then we'll talk about it afterwards, all right? So 1 minute, go.
Unbiased, systematic reasoning. How do you systematic get that?
I didn't know how to explain it, so I just
All right, guys, so same directions. It says determine the quality of cell phones coming off an assembly line. The manager chooses one cell phone every 20 minutes and checks it. All right? So, well, what I'm taking a look at is of course, and you can, believe it or not, guys, you can actually, you kind of saw me do it a second ago, with steps, you can almost go in reverse order, and it might help some people to go in reverse order, right? Read the directions, find out why, find out the why first. And then, of course, that will lead you, of course, to maybe whatever looks wrong with it, that leads you to, of course, which one it is, which, of course, will then describe if it's biased or unbiased. Okay? So if I do it that way, I'm taking a look and saying, okay, well, one thing I notice, talking about the why, is it's just every 20 minutes, right? They go to the assembly line, grab one, checks it. Every 20 minutes. Okay, that one's good. Just maybe to check the machine to make sure they're running well, right? So I take a look. Well, I do actually kind of remember part of the time, right? So if I find it here, I'm taking a look, and I see one of my vocabs that says the every 20 minutes a customer is chosen. Well, it's not a customer chosen, but in this case, I believe it still is 20 minutes, and it's a cell phone. A sampling method in which the items or people are selected according to a specific time or time interval. Systematic, random sample, okay, which of course is an unbiased way of doing things. So, if I go to write that, right, the population is trying to find if these cell phones coming off the assembly line are good, the quality, right? So that is the population, but just right off the assembly line, grab them straight from the assembly line. It is unbiased. And what did I say? It's a systematic random sample. And I could say why? Well, like it just says. they were chosen with a specific time interval. Oops. Maybe I can, in parentheses, put every 20 minutes. All right, questions?
So basically, for unbiased, so you're basically like justifying it, and for biased, you're giving it why it's
Biased, yes. If it's biased, something's wrong with it. So you're kind of like poking holes in what's wrong with it, and then basically unbiased, you're backing it up with why is it? You're giving proof of why it's a good sampling. Is that I might just restate it? Okay, yeah, that's basically what we're doing. Yep. Okay. Any questions on those? Other questions on those type of problems? Okay. Now, if you remember right, understanding sampling and good sampling is kind of mainly what this lesson's about. You see most of the vocab, but this part we haven't done yet, and that's actually what we're going to do next. We're going to take it to the next level. All right, and let's take a look on page 464 at problem number 4. All right, problem number 4 says the theater group took a survey about the type of popcorn they should sell during plays. It tells you they randomly surveyed 52 students at lunch. So they're telling you it's random, it's unbiased. Okay, so that's not what they're asking us to find. Then it goes on, it says their results are shown in the table. Is this sampling method valid? If so, how many of the boxes of popcorn should be caramel if they order 600 boxes? So I stand corrected. It does. That little sentence right in the middle says, is this sampling method valid? All right. So in this particular case, I guess we could just say this is step 1 or even step star, just to answer it. And because it says it says they randomly surveyed 52 students at lunch, it says, is this sampling method valid? It is valid because it is random sampling. Okay. Okay, so if I take a look here, okay, this is surveys on types of popcorn to sell. You have flavored popcorn, all the different flavors, number of students, right? So if you take a look, it says they randomly surveyed 52 students at lunch. Their results are shown in the table. Okay, obviously sampling valid, we already talked about. How many of the boxes of popcorn should be caramel if they order? So caramel is the main part. So here's what you're going to do. They took a sample of 52 students. It was random, so it's good sampling. 52 students. Okay, caramel, 13 preferred it out of the 52. So here's what you're going to do. We can call this step 2 in this particular problem. You're going to write the fraction or the ratio of students who preferred caramel. So it was 13 out of the 52. And this is all based on your sample. Now here's what we're going to do. Remember it talked about predicting? We're going to use a tool we haven't talked about in a while. We're going to use a proportion. Now here's what we do with step 4. We don't use the sample. We're going to use Okay, so I'm rereading the question. It's always good to reread the question. It says, if so, how many of the boxes of popcorn should be caramel if they order 600 boxes? Okay, so here's what we're going to do. All right, step 4 is basically what this is doing. Step 2 is giving us the fraction of the popcorn, right, or the fraction of the people that's going to eat that type of popcorn. So what we're doing is it's not giving us 600 people, but it's just talking about still the same ratio, 600 boxes. That is what's going to go on the bottom. So what we did is we set up our proportion. Now it's been a little while, right? But step 5, 50, if this was like 520, you just go, oh, 52 times 10, right? But that's not necessarily true here. Remember, cross products are equal. So that means 13 times 600 is equal to 52 times whatever's missing up here, which we'll just call it x. So simplify this side. 13 times 600 equals 7,800. And simplify this side, which is 52x. All right. Of course, we're dividing both sides by 52. So we end up with x, and so we have 7,800 divided by 52, and we get 150. Now remember, this isn't in people, but it is the fraction part we use. It is 150 boxes. So it's asking you on your question for those two answers. Is it valid? And then use it to predict how many boxes to order. All right, guys, questions on that? All right, so using sampling to predict.